Welcome to Tuesday. I know you're as excited as I am. So today we're going to talk about expanding logarithms. Now, the purpose of this is that we're going to be, writing logarithms as single monomials in an attempt to simplify. So expand means make bigger. So we're going to take something that's small and stretch it out to make it bigger in hopes that we could simplify some of the pieces as opposed to being able to simplify it all at the beginning. So again, this is going to be a little awkward at first because this is kind of part of a bigger lesson, and this is just stage one out of about 4 or 5 stages. So again, we're going to be working on the little stages, and then eventually we'll start putting it all together. So it's okay if it's a little confusing today. Hopefully it's easy enough, but you might not feel like you're very comfortable with this. All right, so today we're going to talk about what's called the product rule. It says if lowercase b, capital M, and capital N are positive real numbers, with b not equal to 1, and the reason we don't b equal to 1 is because it's our base number. We don't want our base number to be 1 because 1 to the second power equals 1, and 1 to the third power equals 1, and 1 to the 47th power equals 1, and nothing really works with that. So the idea is this. If we have log base b of two numbers being times together, this m times n, what we can do is we can split them apart, rewriting the log base b for each part and then separating them with a plus sign. And that's where going back up to here where it says related to exponent rules. I don't know if you remember exponent rules, but when you did something like x to the second power times x to the third power, how you added those exponents. It said multiply, but you added. Same thing here. Here it says multiply, but when we split it out, it ends up being add. So again, it's related to exponent rules because logarithms and exponents are kind of much the same thing. So let's look at some with actual numbers in it. I think you'll make more sense out of it when you can see things that don't have so many letters. All right, so first example here. Log base 6 of 4 times 7. Obviously 4 times 7 is 28. But what we're saying is we could split this out. Split out the 4 and the 7, both still keeping the base 6 and switching to a plus. Now the reason I would do this is maybe I know the answer to one of these pieces. Maybe I don't. We want to check to see if we can find the answer to either of those pieces. If not, then we're done. So log base 6 of 4. Let's think about that again. That means 6 to some power equals 4. Is that something I know the answer to right away? No, I don't. So nothing's going to be done there. Over here, this is log base 6 to some power equals 7. Is that one I just know? And of course not. I don't know that at all. So that means I'm done. I expanded it. I stretched it out. Let's try another one. Log base 5 of 6 times x. So obviously I can't do 6 times x, but what I can do is I can split this out. I can split out the 6 and the x, each of them keeping their own log base 5, but since they were multiply, it switches to now plus. And again, if I could do some of these, I would. On this first one here, base 5, I don't know the answer, so I'll just call it, w, and it's supposed to equal 6, 5 to, no, I don't know. You're not going to be able to finish most of these. Same with this next one here. 5 to some power equals x. No, there's not much to do. You'll see when we get to one in a moment when there is something that we can do besides just split them out right now. Again, remember, this is step 1 of a 5 or 6 step process, and again, it might not make total sense as to why we're doing this right now. It will down the road, but right now it probably doesn't make much sense why we just took the time to do that. All right, let's try another one. This also works with natural logs. And again, it's no big deal if you don't understand the whole idea of what the E number is all about. Again, unless you become an accountant, you'll probably never use that anyway. All right, so natural log of 6 times x. Again, I can split this out. Natural log of 6, natural log of x. They both keep their own natural log symbol, kind of a little bit like distributive property, except for, again, it went from multiply to plus. And again, I don't know the answer of natural log 6 or natural log x, so I'm just done. Next one. Maybe this is the one where we find out about what we can actually simplify. Log base 10. There's a reason that the calculator knows these so well. Because, again, these make sense. So log base 10 of 100 times x. So they can both keep their base 10, but I'm not going to write it because that's called a common log. Base 10 is so normal, we don't even write the exponent or the little subscript 10 anymore. And again, it used to be multiply, and now I'm switching it to plus. And this is where I got one that I know. Right there. Okay, think about what that is. 10 to some unknown power is supposed to equal 100. Remember, the base is 10. 10 to the second power makes 100, right? So that means I can replace that part of the answer with a 2, because, again, log base 10 of 100 equals 2. It's a way to find a missing exponent. Now, the log x I cannot find. That is the purpose of us splitting it out, is for that stuff to happen. Again, some of these other ones it didn't, because I'm giving you simple ones right now. Right? But again, in more common logarithms, like this one, that's going to happen sometimes for us. Alright, try a couple more. Alright, these ones got a little twist in this one as well. Because what I'm hoping that you're seeing is this natural log of 3x squared is really the same thing as natural log of 3 times x times x. That x squared is really 2x's. So when I expand this, I should really have natural log 3 plus natural log, well, I spelled it wrong, there's no I in there, plus natural log, again, x squared, but that can be split, because that's really two things times each other. So we end up with 2, I did it again, 2 natural log x's instead of just 1. So this ended up with 1, 2, 3 monomial parts. Now again, outside of the base 10s, you're probably not going to be able to simplify much of anything. Now, maybe, but probably not. This next one's one of those maybe ones. All right, in our last example. All right, so again, log base 2 of 16 times 5. So what I can do, again, is I can split this out. Log base 2 of 16 plus log base 2 of 5. They each get their own log base 2. And there's a plus sign instead of a multiply sign. Again, maybe you know the answer to one of these. Like this one over here. 2 to what power equals 16? Well, maybe you know that 2 to the second power is 4, and 2 to the third power is 8, and 2 to the fourth power makes 16. So since that 2 to the fourth power means I can replace this whole answer with 4. Now on this one, on the other side, if I was trying to do the same thing, I would have been the same thing as 2 to what power equals 5. And again, 2 squared equals 4, 2 to the third equals 8. We skipped right over 5. There's no easy, simple, basic answer to that. So that part wouldn't simplify. So again, it's not easy because it's so awkward and it's new, and I know logarithms are not something you're comfortable with yet. But hopefully it's basic enough that you'll have a fighting chance, except for maybe some of the little tricky ones. All right? If you just want to check some answers, hit me up on the Zoom, or if you need any help, same thing. Good luck.